Hi, good night, everyone. Good night, everyone. So I wish you have had a very good student vacation week. So I know some students come to still come to the union and also catch up for the project. I think this is a very good time. So basically, like in the early student feedback survey, some students suggest like we should maybe more focus on some technical stuff, and also we need maybe when we play a video or things, we need from start to the end. I think they are all very good suggestions. But all the things and other things like they want to have a more hands-on experience. And today, last week I discussed with our head of school and the deputy head of school of teaching, and basically we will support. And today I received an email from deputy head of school for teaching, like we for face-to-face, we still need to keep social distance. So if you cannot keep the social distance within the social distance requirements, you need to have a wear a mask. So this is a requirement, and but we will do our best to give you the opportunity to work face to face. But I think it is cannot be as normal teaching. We cannot give very everyone to have the same time of as normal, but we will do our best. Especially, I think now is a very crucial time. We need to finish our assignment 2 and project, final project on time. So I want to use this lecture, especially during the lab time. I will visit each group individually to see what's the difficulties you would have. But today, I want to emphasize is we need to be concentrate, and also during my lecture, if you have any concern, just like stop me and we can discuss. I think like we should have a very well prepared for the final stage. So now we start to our class today. So today, according to our plan, is discuss about electronic nose. So electron nose is artificial nose. Is like is we use a gas sensor. Like you know the gas sensor. So they are sensitive with the particular gas. For example, for oxygen or for the carbon dioxide, some is sensitive with some particular gas, and we use not only one, we use several to build eNose. So I think there's one group student select eNose as the project. So this project is basically not only they include both sensor theory and also artificial intelligence. Next week, we will invite a guest lecturer. That's called Professor Peter Watson. He will give us a very good commercialization product. It's like it's artificial heart. So this one I think I hope you can all join that. So but today's lecture I will be a little quick. One is introduce about have you looked at the UTS online sorry the canvas. So in the canvas I put module like we go there. So if you look at week 8. So week 8, basically this is have something related with eNotes. So eNotes, like this is the eNotes technology. I hope you read after class or before class. And I put several videos. So especially the first video is very interesting to introduce about what is eNotes. So I also have prepared slides, PPT file to introduce about eNotes.
You've probably noticed that whenever you have a cold, your nose gets all stuffy. And when your nose gets all stuffy, with a bunch of stuff, you're not able to taste things very well. So let's imagine that you're trying to eat a strawberry. So you're eating the strawberry, it tastes really good.
So you cannot hear the video.
Welcome to 2-Minute Neuroscience,
and as you're chewing the
where I explain neuroscience topics in 2 minutes or less. In this installment...
Excuse me? Can you hear the video?
We cannot hear the video.
Cannot hear the video. Yeah. So I leave this one for you to watch after class. So do you feel like the Zoom have some problems sometimes more than Teams? Because in the future maybe we change to Team, but currently it's maybe a little bit late. But we look at probably I still back to the first module. So this is the one. We have several video I want you to watch. I try this one again to see whether you can hear.
We're developing a bioelectronic nose, or cyber nose, a portable device that can be used to smell.
One of the key features of an animal's nose is just how sensitive.
Can you hear this one?
No.
Oh.
No.
In that case, maybe I leave all this video for you after class. You watch it. So maybe I use my my slides. I introduce what's eNotes. So like so you can watch the can you see this one? Can you see my screen? Hello? Hello everyone? Hello? Hello everyone, can you hear me?
Yeah.
So you can hear, right?
Can hear you, yeah.
We can.
Yeah, that's great. Yeah, thank you. So in that case, we continue with have you seen the slides? Should be okay, right? Design of eNotes.
Yeah, we can see that.
Can you see this? This one?
Yes.
Yeah, okay. So I continue. So this is we design electronic notes. Actually, here we have the eNotes model is like something like this. This is the eNotes. I think maybe I change the setting. Oh, video setting, I think. So this is a this is the OE nodes. Actually, this is the we developed within I think 2 years. We have several versions of the eNodes. These eNodes we have developed for 2 years already, and we have other new type of eNodes. I will show you later. But the eNodes actually, I show what's eNodes. Actually, electron nodes. What's the theory? What's the theory behind that? Something like this. So you can see this is our human olfactory system. So it's like we use our human olfactory system smell things. So we have a sensor like sensor things, and we also have something like called bulb, called olfactory bulb. This one is something like similar like a microcontroller. And also we have brain. Brain is something like a computer. Like we look at this is the analog of the human olfactory system and the eNose. So this is a real nose system, olfactory system of human. So this is like for dogs they are even more sophisticated. So that's human. We developed similar things. So for example, we have an apple. We want to identify the smell of the apple. We design this called sensor array. This one you can see we have 10 sensors. So actually this is a sensor board. Actually in previous year we asked students to build a hardware, use chips and resistors and capacitors to build and also operate op-amp to build the sensor board, and to develop a very simple sensoring circuit, use gas sensors. So this first part is a sensor array, and then this is a olfactory bulb is something like a microcontroller, so microcontroller unit. So this is a brain. A brain is actually like a classification. Like basically you have lots of sensor here. Olfactory receptor is a sensor. So human sensor is much more than 8. So because we use 10 sensor, maybe we need to select because the sensor number 1 is very expensive. Some sensor is quite expensive. Number 2, it will cost some energy. So we not use very many sensors unless it is necessary. So normally we even 10 we think is too much. For example, we currently have a project with Sydney Fish Market. We build a eNose. We want to detect the freshness of the fish. So for that one, we actually only needed to use 2 sensors. Finally, we use 8, and then we reduce the number of sensors. But anyway, for the human brain and also the PC is actually it will implement the classification algorithm. So the MCU or the olfactory bubble, they are all do the simple signal processing task. For example, the feature extraction or do filtering. I think is in this stage, and use the PC computer or brain is mainly do classification. After you develop a classification algorithm, this one maybe is a like neural network, or is sometimes we use fuzzy logic, sometimes we use support vector machine, some classification algorithm. So I will discuss with you because in the next week, maybe some groups after submit assignment 2, we need to concentrate on the project. So the next major task, there's several groups, they will use classification. So I will maybe discuss about classification learner, and if necessary, we discuss more about classification. So this is the overall. So this is the what the electron nodes look like. So basically, they also need to have some other part. For example, you want to control the airflow come into there's a chamber. The chamber, we put all the sensor into the chamber, and we also need the gas come into the chamber and well mixed because we want to that evenly distributed. So you can see here we put sensor there, and the actuator actually is pump. We suck in the air and then mix them together, and then we data pre-processing. So you can see there's a microcontroller there, and then we use a PC to do all the classifier. We implement the classification, and then they get result. So we also actually the eNodes is good thing is because they are very portable. They are not very portable. They are relatively small, can be built it as portable one. So you can see this is called the GCGC. This is the more accurate one, but it's very huge, very big. And there's also other some electrical nodes in the market and also in some research area, research organization. Some of them is very expensive, but some is very big, too big. And also doing the exercise is not automatic, will be time consuming. So for all one, we will build portable and low cost and high performance and multi-purpose, simple to use. So this is the block diagram of the eNodes, how we build it. So we have also some hypothesis, some like application, for example, for food safety and also for health and for wildlife products, and also actual wildlife protection like elephant trunk. So we need to protect, and also agriculture environment protection. We can monitor the pollution and as well. So also can detect drugs. And also for the health related, like for eNodes, they can even develop some eNodes to detect some diseases. For example, for the lung cancer, in the society, they already reported. They just use eNodes can detect some cancer, lung cancer, and also stomach cancer. They can develop some products. And also recently, like even I have put in the Canvas, there's a report like said they can use eNodes technology, even can detect coronavirus. So they put eNodes in a room, and if someone have coronavirus, when they come in, they will alarm. So this is a new progress. And also I have seen like recently, like Parkinson, because our aging population is increasing, so some in some area like they want to use eNodes to detect the human olfactory system, because it is found like if you have Parkinson and disease, and normally your olfactory system will have problem. So we want to develop some eNodes. They can objectively to assess the human olfactory system. In the future, we can detect one is called Parkinson, another is Alzheimer's. This is called this another diseases when human brain become too old, and then they will be damaged sometimes. So we need to pre-detect. So this we have several type of eNodes. This is our second generation eNodes. We have some things. This is the response of our eNodes. So we have to do some classification of breath. If you we analyze the breath of human, and also we had to wind classification, some alcohol, and also whiskey classification as well. So we have got some good result. And I don't want to discuss this. Our new generation of eNodes is portable. We don't need to power supply. So this is a remote server. We also use remote server to do some simple process as well. So this is the e-notes. Actually, I put 2 video as well. I don't want to waste too much time. But if you're really interested, I'm very happy to discuss with you anytime. You can just like send me an email. You're interested with the e-notes, and we can discuss in detail. I think this is the for the e-notes part. So another is we will discuss continue with the so this is a pre-work. Pre-work I also put another thing. It's called analog to digital conversion, because you know like why I want to discuss with you now is the time to discuss about that. Because this is I mean today mainly the pre-work. Now is very focused. We will focus on number 1 is assignment 2. So for assignment 2, someone asked the question about the report and the video clip. So I sent the email and explained. Actually, each group you only need to submit 1 report, final report, and also 1 video clip, because I think this is a very difficult time, and I noticed some group they are purely from science. So I think this is very challenging for them to submit individual report and individual video clip, because like if you just learn yourself, if you have no other experience about electrical knowledge background, I think it's quite hard. Although we can help you, but the best way is still you learn from your teammate. So that's why I encourage you. I mean, I permit you to just submit 1 report and only 1 video clip. But if your group very strong, if your group is very strong, I think we still give you the other options. So first, I said I put some bonus mark. I will discuss each one by each one. I give you some hint about how to get the bonus mark. Another is like, for example, if some part you have different design strategy, you can write all of the strategy there, and you separately say this is, for example, this is Daniel proposed, and also you put there. And basically, I encourage teamwork. If your team, for example, only some part is very perfect, but there's 1 part is very weak, and then your overall mark will not be good. So that means like if you want to get very high mark, individual high mark, you need to guarantee like your team mark is good enough. And after that, if you your team is very good and you put some other more sophisticated design, and then you will get a very good mark. So that's my explanation about the requirements. For the final report, we also similarly similar requirements. For in the report, you need to clearly identify this. For example, this is Daniel's work. This is Michelle's work. This is Emily's work. So we need to very clear. So in this case, I strongly suggest. I'm not sure assignment 2 is possible. Still possible. We have 1 week to go. So I hope like the team leader can make something like a contract with each member, said which part you should finish by what time, and then the whole group discuss about whether we adopt this part written by some particular member. So we need to make a plan now. Now I quickly finish the pre-work and discuss about assignment 2. So we go back, go to next. So I have put some thing is FFT because first we if we look at the analog digital conversion, so this is a time we discuss about analog to digital conversion. So you know, like after you design the digital analog signal, the next step in nowadays they all need to be digitalized. That means you need to AD conversion. So AD conversion is a very critical critical part because you know, like signal processing, digital signal processing is very sophisticated. So I will show you later. Just like use MATLAB, we can implement notch filter easily. So basically, I go quickly about the analog to digital conversion system. So what's the main problem and what we should be take care of? We need to I give you some emphasis, and then I will quickly to discuss with you about assignment 2 again, and during the lifetime, I will go to each group to discuss about assignment 2 and the final project, mainly assignment 2. So we look at analog to digital conversion. Actually, for analog digital conversion, we have a 4 step. So one is for sampling. Sampling is like sampling theorem. I discussed last week, but I will introduce. I will discuss very soon as well. And you need to sample and hold. What that means, like you have a signal, you want to measure how big it is. You first make a discrete time, so you need to sample. That means you use a capacitor to charge the capacitor, and then hold the capacitor for a while, and let the computer to test. This have several comparators. They can quantify first sampling and then quantify the amount, and then you need coding. So they have different code to express to describe the amount of voltage or current you measured, the continuous the sampled signal, and then you construction. Then use for example, they use digital to analog conversion. You can come back, and then use filtering, come back to the original signal. So this is some example for data acquisition and the distribution system. So this is a motor, like I think this is like system under control. There's a control system, and then the signal processing in dance. So they have microcontroller, and the analog to digital conversion, digital to analog conversion is here. So normally this one, after the analog digital conversion, first this part you already designed. This is sensor, transducer, and the signal analog signal conditioning. You design IT aliasing filter and things, and then you use sample and hold, and then you AD conversion, and then this is a computer microcontroller, and then you back to the original signal. So you digital to analog, and then low pass, and then you come to the signal. Basic specification is like how many. If you want to ADC accurate, you need to have a high. The number of bits should be high. So now you can easily purchase AD conversion, but AD conversion, to be honest, is very expensive compared to other components. So if a good AD conversion, a converter even is more expensive than a microcontroller, some microcontroller. Today I just want to discuss the sampling, signal sampling. So sampling theorem, last week I discussed like your sampling rate should be fast enough. So maybe we look at this sampling theorem here. So actually it's like, for example, why we need a fast sample. If the signal change very slow, and then you can use a slow sampling rate. But if the signal change very fast, you need a fast sampling rate. So the quantitating and the things I will make it quickly. So today I mainly want to discuss about the Nyquist sampling theorem. So they need to be, the sampling rate should be greater than 2 FH. FH is the highest frequency. So that's why here we need to sometimes design anti-aliasing filter. So just I want to ask, do you know which part is the filter you designed is anti-aliasing filter in your assignment 2? Is any group start to design assignment to design the ECG? Yeah, if you have designed, I think they have a low pass, high pass, and sometimes maybe you design a notch filter as well. So which part is for the anti-aliasing? Actually, it's the low pass filter. It's anti-aliasing filter, right? So mainly, if the sampling rate cannot be high enough, you have another way is you can limit the highest bandwidth of the input signal. So here is give you some example. For example, if the sampling rate, this is only the sampling rate is 1.3 times of highest sampling rate. So you can see this have aliasing. So your original signal, the frequency is faster, is higher than the sampled. So if it's just two, if fs equal 2 times of highest frequency, you can recover it. But this is for the very ideal case. For example, if you sample at 0 point and then all your signals still 0. So in that case, fs equals to 2 fh is only necessary condition for recover the signal. It's not sufficient. So if you want to sufficiently enough, at least 4 times of highest frequency. So in the practical situation, so even more. So actually in the real situation, the suggestion is fs is 8 times of highest frequency. So this one is give you some explanation for the aliasing. So aliasing, the one I already explained, I think in the lecture, last one. But I will quickly discuss later about sampling theorem. So this is some example. I give you, I put the answer and everything there as well. You can try to solve these things. I think because you are busy with assignment 2, I just like this one leave you for later. If you have any problem want to discuss with me, and just let me know. So this is lots of very important concept, and I think we don't have time to discuss all of them. But here I put this slides is mainly onto you to understand the sampling theorem. And also I want to discuss very important thing is like nowadays if you have an aliasing filter for the analog signal conditioning that's good enough. So normally they put all other filter into a digital case. So that's why I want to discuss we have to design the anti-aliasing filter. So this sampling rate and also aptitude time and the sampling error. So this thing discuss about the more fast you sampled, the less error you can get. We discuss about intersample error and also aptitude error. So they have give you the formulas. So and also they have some example how to determine. For example, so I discussed before, the more digits you can get less error. So you need to based on your requirements, you need to select the suitable analog digital converter, not necessarily the expensive the better. So this one is a dynamic error. So dynamic error is like we treated it as a first order system. So we can also discuss about analog to digital conversion. So here I put this some example as well. I already put this one as pre-work. I'm not sure how many students have time to read it. But now it's I think after I explain this, you can go after you go home. Maybe you can continue with this, and next we go to this is I put some video or some website discuss about digital filter. After AD conversion, you have lots of method to manipulate the signal, to clean the signal. So one is like you can use FFT, so fast Fourier transform. So this is a digital, use digital method. And I give you use MATLAB. You just one command, you can do it. So this one is I will give you all the in the video and the things. So that means after you go to digital area, you have lots of method to use. For example, I show you you use MATLAB. For example, we have a ECG, right? We ECG, but we have a polluted. So if we have polluted signal, here we look at our ECG signal. I put someone check. Yes, we will discuss assignment 2 quickly. But I before that, I just like quickly see like why I put lots of material, ask you to read. It's about the digital side. So digital side is because it's powerful. Because in the assignment 2, if you cannot design the notch filter, the analog notch filter, you can design a digital notch filter here. So you can see I show you how powerful is the digital filter. So if you look at here, so here is the MATLAB code. Here we can use ECG. This ECG signal you can generate yourself, and I put some noise as well. So I want to use digital filter to get rid of this noise. So first we run this. So this some design filter is quite easy, just like one sentence. You can design filter. Either this is low pass or band pass. This is a notch filter. The second one is notch filter. Actually, I'm design a notch filter. So you can see MATLAB will design it for me. Just the notch filter is just one sentence, one difference equation. If you design, I will show you how to design a analog notch filter. Is much complex. They got the double T structure. So but this one you can see I designed like this 50 Hertz noise. It's get rid of the 50 noise. So we look at one by one. So this is original signal, right? But they have some noise here, 50 Hertz noise. I put some 50 Hertz noise, and this the 50 Hertz noise. You can see the noise have some. If you do FFT to your signal for your project, maybe you can see them 50 Hertz component. So my one is a double side spectrum. So you can see you have a positive 50 Hertz and negative 50 Hertz. So in that case, we need to get rid of this kind of 50 Hertz noise. So this is our magnitude response. You can see. So this is called notch because for other frequency, this is not change. It's because log 0 is 1. So that means for other signal, you have no rejection. So it's nearly it's similar as the signal before, but close to 50 Hertz, they can be as low as negative 40 dB. So what's the value of negative 40 dB? Can you transfer to the ratio? It's actually 0.01. It's 100 times smaller. So at 50 Hertz. So reject. So we look at the further look at the result. So this is the polluted signal. So this one we use FIR filter to design, right? So this is the original signal, and the blue one is original signal, but the filtered signal is the red one, because of I think the random signal they cannot filter very well. If I put 50 hertz, I put 50 hertz as bigger. I put random noise smaller, and then I put this one is bigger. So we look at what's the result. So we use notch filter. We use FIR notch filter. So there's just one, you can see just one command, and then this notch filter is done. So this is a linear phase as well. So delay is 40. So you can see the green one is actually so it's well you can see the so the magnitude is you can see the this implement the rejection, and also yeah. So the filtered signal before is they polluted this one 50 hertz is very big. Now it's much smaller. So this smaller signal. If I this is original the filtered signal. So I think original filtered. So in the previous year, because last year we forced students to implement the analog filter. Some group use double T structure implement the notch filter. Although the design quite good, but when they try to implement it, it's very complex. Sometimes even cannot implement. But we give them another choice. They can use digital filter. They just use the one command here, the design filter, and then they can design a digital filter, and then they can implement the notch filter. It is permitted for this semester because you no need to really implement the notch filter, but I still give you the choice. You can either use multi-sim to implement the notch filter, or you can just use MATLAB. After you use MATLAB, you can use after you get the digital signal, you use MATLAB to get rid of 50 hertz noise. So really depends on you. Hello?
I'm not sure what the notch filter is useful for. What are we suppressing when we use notch filter?
So why the question is why we needed to design a notch filter, right?
Yeah, I thought it was because of the power line.
Yeah, power line. Yeah, 50 hertz. Because of the power supply is 50 hertz. Because power supply have a very can generate magnetic electrical magnetic interference. So this one will generate, because our signal ECG is relatively weak, and if you generate interference 50 hertz, we need to get rid of. So because this is from the power, is 50 hertz. I think maybe some group project already noticed that, right?
Yeah, but it means that each time that it's going through an op-amp, for example, is going to have a problem because your op-amp is supplied by a power line.
So you want to discuss about design an analog filter, right? Analog notch filter.
No, my question is more where the border line is a problem, where it's going to alterate the signal.
Oh, it's a good question. Actually, because you know, like when you design a circuit, ECG circuit, right? You have some electrodes and some lines, and you know, like if you form a loop, when the loop area was interferenced by the electromagnetic field, if the magnetic field is changing, and then you will generate the voltage, disturbance voltage, according to the law. I mean, the changing, the varying of the magnetic field, and also generates some varying electric voltage, right?
Okay.
Yeah. So in that case, we everywhere possibly can generate the disturbance. So we need to design a filter to get rid of this 50 hertz noise.
Okay.
Yeah.
Thank you.
Yeah, can be come to any line from the circuit. Yeah. So now we look at because we need to focus on the assignment 2. So I stop here for the digital side. We come back to the analog side again. So first I want to see there's a 3 bonus part, right? One is do you remember what's the first one? Is notch filter, right? Actually, notch filter, if you search in the website, there's lots of website called the notch filter. Notch filter, maybe analog notch filter. So it's the most commonly used is double T structure. I think I'm not like go too deep. Like maybe you can find like somewhere, and then they will teach you how to design the double T one. So I think I leave it to you, because for this project, for this subject, all in the future, we cannot teach you everything. Actually, no matter you learn hardware thing or software thing, I think the most useful resources is from the website. So you need to learn how to search in the website, and especially if you are a UTS student, you can go to the library. First you Google and you find something. UTS library, actually we stored all the necessary papers and the equipment. Papers and thesis you can use. So it's very convenient. But you need to learn how to use these resources. So for the notch filter, I think the structure is already there, but you need to think about how to implement it. And also for the filter, I want to emphasize this very important thing. Maybe for this semester, it is not that critical, but in the previous semester, it's very very critical. So one is like when you select, sometimes you select op-amp, sometimes you select even just like small as a capacitor or the resistor. So you need to, previous year, you need to purchase them. So you need to go to JACA or element 14, you need to find them. In the previous year's experience, some students purchase for the filter, they purchase a polarized capacitor. And also they designed the value is very big. So more than 1 microfarad. So it's too big. And also sometimes they select the parameter, the resistor value is also too big. So I remember when I discuss about the filter design, it reminded you, first you need to select non-polarized capacitor. The non-polarized capacitor normally have a big size, but because your filter is working in both positive voltage and also negative voltage, so you need to use non-polarized capacitor. And also you need to select small value. Not too big, the value of both capacitor and also the resistor. because if that was too big, and for the resistor, the problem is like they will generate some noise. For the capacitor, it's too big. The size is too big. Yeah. That's we look at the notch filter. I think I have some. I did a notch filter myself, but I tell you how to test it because I don't want to let you give you everything, but I can make it small. But first you need to have a. So this is the oscilloscope. So after you design, how to tell your design is accurate. So there's one way. It's very simple. Some student already sent me email said whether we can use body plotter to do the test very easily. I think this is a theoretically, I mean, this is okay. And even in the lab, but in our lab, in UTS lab, we don't have this called this actually called signal analyzer. So we don't have the hardware analyzer, but for the multi-sim, they have the similar things. They can design. This is actually the body plot. All these are called frequency response. They have both magnitude and the phase. So this is the notch filter. You can notch filter. You need to know what this. This one should be 50 hertz, right? You can check whether this 50 hertz or not. So you can check. So this is 50 hertz, right? It's negative 46, 47 dB. So it's this is very small, right? So this design looks similar, seems good. So, but I'm not encouraged to use this body plot one. I think I encourage you to use just use oscilloscope. So you can see my oscilloscope. This one is input, one is output. So my channel one is input. So my channel one is input. If I increase this one, you can this smaller one is input, but this one thing maybe I change the scale to the same. Is I think is 1 volts. 1 volts, one div, and then this is the same scale. You can see for here what's the frequency I input. I think I check. So my input is 120 hertz. So 120 hertz maybe is not big enough. If I put 200 hertz, I think this one should be no influence for the output. So in that case, I simulate. So you can see they are nearly the same, right? So they are not in the notch frequency. So if I change this one to 0 hertz, sorry, 10 hertz, I mean, maybe 2 hertz, 5 hertz, and then this one is also should be quite similar, but it's very slow. Yeah, good question. Yak asked because there's a phase shift. So actually, this is a very normal. They have a phase shift. Actually, I will see like I will show you like in the digital one, they also have phase shift, but that one is a linear phase. But no matter what kind of design, no matter it's digital or you analog, they must have a phase shift. So you can see theoretically here. So they have phase shift as well. You can see they have phase shift as well, right? So this one is also have phase shift. This is a linear phase. It's better than the previous one. So you can see the phase shift is linearly with the frequency. So this is a linear phase will have no signal distortion. I will discuss in the other class, but don't I mean we still go back to the multi-sim. So the multi-sim you can see if it's a very low frequency with 5 hertz, it seems they are nearly the same. So that's what we want to see, right? It's nearly the same, but still have a phase shift. So someone asked, that's very important. So in the report, if you can put more your understanding, the more the better. So you need to, because in this semester we don't have any implementation task. So I give you maybe more. One is the demonstration. You use a video clip. Another is the report. So, but if we check the 50 hertz, because we all design want to 50 hertz have side rejection, right? So if I put this one to 50 hertz, so this actually is called frequency analysis. So you give a particular input, sinusoid signal. For linear system, no matter what kind of filter, I explained, like we design, is all linear filter. So they are all linear time invariant filter, called the linear time invariant system. So the input is sinusoid, output is also sinusoid. They only change the frequency, even frequency not change. They only change the magnitude and phase. So you can draw, actually theoretically, you can, for each frequency, you can draw for example, a point. So here is a point, right? They give you the point. So here is the frequency. Frequency is 1.7, and the gain is 0 dB. So that's what we want. But you can see for different frequency, you have different gain, right? So in that case, we cannot use the plotter. We just use a sinusoid. For you remember in the requirement of my assignment 2 report, I give you a table for different frequency. You need to do the experiment. For example, here, of course, the 50 hertz is very important. I change to here to 50 hertz and to see what we can get. So 50 hertz, okay, and then we simulate. You will see some other. This is the output will be very small. So you can very small output. You even cannot see how. But if I increase the scale, and then you can see it. So the nearly are not very good sinusoid because they are too small, have some nonlinearity get in. I think because this multi-sim is try to be consistent with the real situation. So I think that's what we designed, right? This is the notch filter. Of course, we have some protection circuit. One is called diode protection circuit. So for the diode protection circuit, there's some you can in the website. There's lots of suggestions, and for example, something like this, I make it. So this diode protection, and also something like this, some circuit. They are all you can use. If you can give a good explanation. I don't want to show you all the things, and if you can give a good explanation of your design, that's good enough. Yeah, for the maximum page, I think 50 pages is we suggested. If you want to put more, you can put it to a appendix, but don't over 20, for example, 20 page. I think you can have extra 5 page, because like maybe 20 is a maximum. Hi, Kari. I think 20 maybe also easy for us to marking as well. If too long, we may be also difficult for you, because we want to see which is more important for your design. If too many pages, it's hard.
Yeah,
so,
I think 15 to 20 is reasonable.
Yeah, 15 to 20 is maximum, right? And also another one is called red light driven or red light protection circuit. So this one actually I have video very good. You can see there's several videos. Some students ask question. Okay, so I think because it's 7 o'clock nearly, but I show you what's the protection circuit. Actually, in our I think in our in the canvas, I put this one. I think in the module module in the week two module. Because we need to go to the lab, some students want to go to the lab. I think maybe we just like stop here. But there's we have some thing. I think week two. I put week two. There's a chapter just discuss about the ECG. So here in here they have the protection circuit. Actually, in the website there's lots of right leg driven protection, right leg driven circuit. Actually, the circuit number one, they can reject the the common mode gain, so they can reduce the common mode rejection ratio. That further increase the ratio, but reduce the common mode gain. Will reject some common mode noise. Another is they can protect if there's a shock. Someone touch the power supply, and then they can the circuit, the red light driven circuit can protect your safety. So here give you the structure, something like this, something here. I think here the red light driven red light or red light driven circuit. So I think if you have any problems, you can still send the email to me or to our tutors. We can even organize a special session for the assignment 2, especially for the bonus mark. But I still encourage you to finish at least the fundamental works, especially if your group have some most student is from no engineering background. But we will help you. Don't worry. Yeah. So now it's time to go to the lab. So our lab time is very precious. So thank you everyone. I will see you in the lab, and I will go to the breakout room individually. Hi, Carrie. Hi, Carrie.
Yep.
So we will start in 5 minutes for the lab session.
Yep.
Okay. So see you guys.
So you need to give me to
Oh,
you.
yeah. Sorry. Sorry, I need to give you a. What's Hi, Carrie. I make you a host already.
Yeah. I think it might take a little bit more than 5 minutes. Let's join 7:15.
Okay.
Yep.
Okay. Thank you.
Thank you.